Whether you operate one forklift or thousands, one location or hundreds, the new My Toyota customer portal can help you optimize your operation and material handling equipment. This one-stop, free-to-use platform is designed to help you take control of your information and make smarter decisions, all at the touch of a button. Register and access your data today at my.toyotaforklift.com. That's my.toyotaforklift.com.
Today's warehouse needs to keep inventory moving smoothly and quickly. Meet these challenges with on-demand warehouse labeling from Brother Mobile Solutions. Our mobile and industrial printers will help optimize your operations to achieve the speed, reliability, and durability your warehouse needs. With easy integration for existing warehouse technology, convenient portability, and upfront affordability, Brother Mobile Solutions is at your side when it comes to warehouse labeling. Try one for free today by visiting brothermobilesolutions.com/new warehouse or click the link in the show notes. That's brothermobilesolutions.com/new warehouse to try one for free today.
The New Warehouse Podcast, hosted by Kevin Lawton, is your source for insights and ideas from the distribution, transportation, and logistics industry. A new episode every Monday morning brings you the latest from industry experts and thought leaders. And now, here's Kevin.
Hey, it's Kevin Lawton with the New Warehouse Podcast, bringing you a new episode today. And on today's episode, I am going to be joined by Michael Santora. He is the CEO at Logic, and they are focused on creating a metaverse within the warehouse, focused on digital twin technology, and then translating that over to their robotic solution, the Logic Pallet, as well. Very interesting and kind of looking at automation and robotics in a different way from a vision perspective and an overall kind of grid type of system. Is pretty interesting. I had the pleasure of meeting Michael and I think his partner, co-founder as well at an ABCO event. So shout out to Seth Weisberg over there. But we're going to welcome Michael to the show here and talk all about Logic and kind of how they see the automation in the warehouse space right now. So, Michael, welcome to the show. How are you?
Great. Thank you for having me.
I'm definitely happy to get you on here. Very interesting what you guys have built, and interesting concept and product and technology overall. So definitely interested in learning about that more. But I'm curious to learn first about your background and how you kind of ended up in the supply chain space, because I was checking out a little bit, looking at your background, and you're coming from more of like a architectural design background. So I'm curious how this kind of ended up happening.
That's right. So I am an architect by training, and I've been working as an architect and a real estate developer in New York City for the last 15 years. And two things in that world. One, on the real estate side, we've done a lot of work with warehouses. So I know warehouse design and layout really well. Mm-hmm. I also know the workflows really well, and I've gotten to implement warehouse management systems and things of that nature that tied to the design of the building to make sure that we were building to optimize for the available options of the systems that they were working with. And the other side was digital twins, or is digital twins. So we've been using digital twins as a practice for post-design management of mechanical systems within buildings and analysis of degradation of machinery and things like that. So the concept that we have came as a mix of both of those, the design and efficiency of warehouses itself, and then what the future of digital twins were and what they can do beyond what we're using them for today.
Very interesting, and that makes a ton of sense. Definitely, it's great to be able to see that you've had that experience all the way from designing around a system like a warehouse management system, as you mentioned, to be able to create those workflows and have that familiarity. So definitely great to understand that and understand that that's going into this MetaLogic product technology that you guys have developed as well. So I'm curious, and let's I guess for people, we've talked about digital twins on the podcast previously, but why don't you kind of tell us from your perspective, your definition of what is a digital twin, and maybe where are we in terms of the maturity level or utilization of digital twins within the warehousing industry right now?
Well, currently, I think everyone's definition of a digital twin is a virtual representation of a space. So it could be a Revit model or something like that, where you're creating an exact, highly accurate 3D environment of a space and the equipment within that space. So we're starting with that as well, and that is the backdrop for our user interface, meaning when you look at our system, when you look at the Logic Interface Network, you're looking at a live action digital twin of your space. So it looks like a video game of your space, but you see everything that's occurring in our system in there through the simulated characters that pair to the robots in the field. So the difference between our digital twin and what digital twins are being used for today is our digital twin contains data on physical aspects of the space that control the way robots would operate within that space. Or sorry, I shouldn't say control, I should say affect the way robots operate in that space, meaning the weight that a robot is carrying, the type of floor that it's driving on, the relative humidity in the space, the temperature, all of those things affect the way something can move. But there are coefficients that we can use within our digital twin to predict that. So what we're doing with our system is we are controlling through simulation, and our simulation is highly accurate, not just because of the digital twin, but because of the physical properties that we are integrating into that digital twin to predict how something is going to behave. And then we're using that information to control. And what does that give us? That gives us the ability to run what I like to think of as a hybrid system between the two types of mobile robots that are on the market today, which are AGVs that run within a fixed infrastructure or have some type of physical guidance system that's usually expensive and hard to change, or an AMR, which is completely untethered and able to go all around the warehouse through its own perception systems, but sensitive and expensive because it has machine vision and GPUs and things like that on board each robot. So we're using this digital twin to get the best of both worlds to create a robust, inexpensive mobile robot that is able to move without the limitations of fixed infrastructure within the facility.
It's very interesting. And I think, the digital twin, I think, has so much potential to be able to help operations understand how things can happen through running simulations and things of that nature. And now you guys are utilizing the digital twin to help to navigate and, I guess, like you said, make decisions within the robotic side and guidance, I guess, in a sense of what's going on around that robot and how it's going to impact that. Like you said, like all these things are affecting the movement and how it will move within the space. So tell us a little bit about how you've gone about, well, I guess first tell us exactly what is MetaLogic and what are you guys doing exactly with this digital twin technology?
So we're using the digital twin to control a very, very cost-effective and robust robot, a fleet of robots, I should say. So the idea is that the digital twin is a supplement for the hardware that we're removing from the robots to get the robots down to a cost where someone can scale to mass automation. So I think that the cost of the available systems out there are very high for most people to get to mass automation, save the Walmarts and the Amazons of the world that have tremendous CapEx budgets to invest in these types of programs. Other sizable but not as financially strong companies out there will struggle to get to a fully automated solution with the products that are out there on the market. So what we're doing is creating a way to get the cost of the robots way down and the sensitivity of the robots way down so that you can do more with them. So we created fleets of these very simple mobile robots that look a lot like or function a lot like AGVs, except the digital twin replaces the infrastructure that the AGVs run on. So we don't have that onboarding and that build out cost within the facility. Since we have these robots running without some of the more sensitive things that AMRs have, we're comfortable letting them go on and off vehicles. So we're creating a new sector of automation in the supply chain where there really isn't anything right now. No matter what kind of robots or infrastructure system you have in your warehouse, you're still loading and unloading your trucks with a forklift in typical pallets. You take that and feed it into whatever system you have, and it'll spit out a mixed pallet on the other end, but you're still picking up with a forklift and loading it on the truck. And that's a bottleneck. A truck can wait for a couple of hours at a loading dock, waiting for a person available with a forklift to come and unload it. And that's not only slowing down the throughput of that loading dock, but it's also keeping that truck off the road. It's making the journey longer for that driver and the amount of drive time that they have. So there's a ton of residual effects by improving that part of the process. And that's exactly what we do. So our mobile robot is going to move around the warehouse just like other mobile robots move around the warehouse based on missions that we give it. Come out of storage, go into a picking area, use the circulation cell to get to the other side of the warehouse. But then beyond that, once the items are ready to go, we drive right onto the truck in 5 minutes or less. The truck drives away, goes to the next facility. If that facility is part of our network, the robot connects to that network as the truck aligns with the dock. It drives itself off and it continues to perform its missions there. And we also have a manual control when we're working multi-facility where one party is our customer and another party is outside of our network. They can still remote control the robot and move it around without the link operating it.
Interesting. Okay. That was going to be my question there. You're going to answer that where, so in a sense, definitely see where it could be super beneficial. Like if you're transferring products within your own distribution network, like if you have one warehouse in New Jersey and then you have one in North Carolina or something, you're taking it down, you have that full on network where the robot is kind of integrated throughout the entire distribution network there. Or in other situations, maybe you're going from like a warehouse to a manufacturing facility or something like that. So tell us a little bit more about, you said it's remote control from if you're going to like maybe a customer warehouse or something like that to do the unloading. How does that work and what does that kind of look like?
So I'll walk you through a typical workflow of a multi-warehouse operation where you're not in control of both warehouses. So you're a distribution center for a number of retail stores, and you're bringing in products from manufacturers and suppliers to then sort and store in this facility and outbound to your store. So the typical workflow would be you send a truck of empty Logic pallets up to your supplier. Okay. The supplier drives them off the truck with a remote control, with a manual remote control. And that manual remote control happens two ways in our system. We have a follow me mode where you can connect to the pallet through Bluetooth and it'll follow you around a warehouse, or it's a digital joystick on a smartphone or any tablet that you scan a QR code on our pallet, you connect to it as long as it's on the same network, and you drive it around like you would a remote control car. So you take those pallets off. They're probably not going to leave the loading dock area that they come off in because you're not going to want to take them all around the warehouse and interfere with other things you have going on there. But that's the point where you're palletizing the goods for outbound. So now we have a group of products that are coming to your facility from this partner facility that's not part of the Logic network. They load the items up. Our pallets have weight sensors in them, so we know what the load and load balance is supposed to be before it's stacked. And then we match that with the stack. So we verify, right? Yeah. So now we know the load is correct. We're on there. We drive the pallet back onto the truck with the remote control into a position, and it goes on the road. We have our own tracking system within our pallet. So even if we're not tied into your TMS or you're using a 3PL where their TMS isn't open to you, you can track the pallets directly on the road, and you can even see their weight changes throughout there. So if something lost a substantial amount of weight from point A to point B, you'll know whose responsibility it was and where that thing happened. Sounds like something fell off your pallet and broke or whatever, right? So now you know that that's what leg that's occurred, especially if it's being handled by a third party. Gets to your facility. Once it's at your facility, it can connect to the network. The truck is aligned with the loading dock. We look at the truck when it's parked as a loading dock as an extension of the warehouse. So the truck has very strict alignment to the loading dock, so we can rely on its position. And essentially the space within the truck is map space as an extension of the warehouse. So our system is controlling it in there. Once you're in a system that's under the link's control, in a warehouse that's under the link's control, then the system takes over and our mission planner is driving the robot around through our path planner. So what happens there is your enterprise system is spitting out what has to happen today to fulfill the orders that it accepted in the warehouse. We are taking those orders and processing it just like a warehouse management system does, but instead of a to-do list for humans, we're processing into robotic tasks. So take robot 25 and move it from this position to that position so someone can pick an item off of it or whatever has to happen. We are creating the order of those workflows. We are then path planning so that the robots move around each other effectively in the order that they need to accomplish the tasks. But we're also calculating how we want to stack the pallets that we're making. So in most cases, all of these movements boil down to making a mixed pallet, right? You're either taking an empty pallet and putting items on it, taking a full pallet, taking the items off it, or taking some items from a bunch of different pallets and making a mixed pallet to go out. Making that mixed pallet is a challenge if you don't really know what you're doing. Meaning if you don't have a lot of experience in building mixed pallets, there's no guidelines out there, standard guidelines of how to build it. It's more tacit knowledge. You know what you know because you've done this stuff before or someone's telling you.
Right.
Well, our system actually has all of the data on the box size and strength and the item and everything else in there so that we're deciding how that mixed pallet should be as we create the missions. Meaning, if you're a picker in a interaction area, this is going to work like an ASRS system. We're going to come out of deep storage, which is super condensed, about a third of the size of what the most efficient warehouse is today, because we have no aisles, and I'll get into that a little bit later.
All right.
I'm out of storage, come to me, I'm going to take 2 boxes off of this pallet, put it down. Then the next pallet's going to come to me. I'm going to take a couple boxes off of that and put it down. The UI that's showing me how to pick and the order in which those pallets are coming out are all driven by what the optimal stack is, meaning the heaviest, most stable item in that mixed stack is going to come to you first, and the lightest, most fragile item is going to come to you last, and everything else in between. So you're going to optimize for building level rows. You're never going to exceed the strength rating of the box below you, even all the way up the stack, so you don't crush anything or damage anything by stacking something in the wrong order. And it's all going to stay within the perimeter of it. We don't have that overhang where the edge of the box is off the edge and the whole box crushes.
Right.
Some of those practices that you probably see in other warehouses.
I've definitely seen that. Yeah.
Thinks all of that for you. And all of the missions and path plans for the day are driven by all of those factors.
Very interesting. So, I mean, in that sense too, is it integrating with a WMS, or it's kind of its own standalone WMS too? Because it sounds like it's kind of dictating where to pick and which items to pick first, depending on that. Yeah.
I think that WMSs today have creeped over more into the ERP side. And there are a lot of things within your warehouse management system that are business related, like when you should order more of a certain product because of projections for future demand, things like that could live in an ERP or live in a WMS. We're not in that market. So we can work with a warehouse management system that exists. We can work directly with an enterprise system if there isn't a warehouse management system in there. We're designed to integrate with everyone. All we want to do is take the physical, what needs to be done from whatever system that is, process it, and then send a receipt at intervals throughout the day of what we process so they can reconcile that. But we're not going to overlap with any of those systems. We know that a lot of our beta partners have put a lot of money into those systems, mostly on the business side of things, meaning there are business practices that they are implementing based on the data that they're getting from these systems. So we don't need to unwind that or replace that. Yeah. We just take the physical part of it, the to-do list that was going to your workers, and now turned it into robotic motion.
Interesting. I see. And that makes a lot of sense. And I think it's really interesting too, because you're kind of thinking about all those different aspects where, some just typical AMR may just be, pick up the pallet, move it from point A to point B. Whereas, you guys are taking it a step further and saying like, well, no, you're going to load this product first and then load this product after. You're talking about the weight distribution and all those different things. I think that's a lot and very smart to be doing all that as well to avoid a lot of issues down the road, and also, additional manual intervention where you might have to restack a pallet, or like you said, something's overhanging. It gets caught on the corner of the truck when you're loading, and now, that product is crushed or whatever the case may be, which, as you said, I've seen many times happen. And you try to fix it every time, and, people don't want to listen or just can't make it happen. So, it's great to see those things happen. Now you mentioned too in there something about, there's no aisles involved. So tell us a little bit about kind of, when the product is involved in this Logic Pallet situation, what is this looking like within a warehouse space, and how is it arranged, and what type of space do you need to allow all this to happen with your technology?
On a single level, our density ratio is about 3 times what you can fit in a single level on a very efficient warehouse today that has aisles. So almost every warehouse today has aisles that those pallets can be accessed by forklift.
Right.
And if you take the circulation space between the racks and you take all of the loading space around the warehouse, you almost have about 70% of your building circulation, which is a huge loss. Like if you think about it, now I'm going back to my architect side. If you think about other buildings like apartment buildings or office buildings, your circulation is like 20 to 30% maximum. So having 70% of your building be circulation just so you can get the forklifts around and move everything is really, really inefficient. So we can take the same amount of goods and fit it in a third of the space because we're an aisle storage system. So if you think of a warehouse today like a suburban parking lot where you need a road to get you to every parking space, we're like a Manhattan parking garage where your car is buried behind 10 other cars. But if you call up 10 minutes in advance, they'll move all the other cars around and you'll just be up front waiting for you. So that's how our system works. So instead of having 70% circulation, 10% of our storage area are empty cells. If you imagine a storage area being a grid of cells and each cell being a space that a robotic pallet, which is the same size as a standard shipping pallet, could take, 90% of them will be occupied by a pallet, 10% of them will be open, and we just shuffle them around to make aisles to bring things in and out. So when the system is calculating what's happening throughout the day and saying, okay, we've got to put 20 mixed items or 20 items on this mixed pallet. We need to bring all 20 of these items out of storage. Not only is it bringing it out in the order that you need to stack it, it's also optimizing the movements within based on the free areas. So the pallet that needs to come out third may end up coming out of storage first and queuing up somewhere in the interaction area because it was available to come out and it was going to take way more moves to pull it out third later. Right? So the system is always optimizing and minimizing the amount of moves in there. So you can think of the storage area as not a static area like we do today, but an area that is always optimizing and always rearranging itself, even if things aren't coming in and out of it. As orders change and as other activities happen, as it decompresses because we have things out, or as it compresses because we're taking things in, we are constantly moving and reacting to that and optimizing for what needs to be coming out next.
Very interesting. And I think it's really incredible. I mean, how you guys have thought about the optimization at every level within the process. And I think that probably goes back to your experience with, working and creating these design workflows within warehouses and things like that. I mean, it makes a ton of sense to be thinking in that way. And like you said, pulling something maybe out of order in the queue because it's less moves, but then, queuing that and having that weight. And so that the right sequence of picks or loading onto a pallet happens and makes the most logical sense from a weight distribution, packing perspective. It's really incredible to see how kind of deeply you've thought through this and developed this so that it's hitting all those marks and hitting all those different levels within the workflow. So, I mean, in terms of like space to do this, like if I had an operation now and, I wanted to bring this into my operation, I mean, would this kind of totally replace everything I'm doing now, or would this be ideal for like one part of the process? What is kind of the picture, if I'm going to bring in Logic Pallets and MetaLogic into my operation? Am I looking to now like replace the racking I have, or just a small portion? What does that look like?
We'll be back after a quick break.
You hear a lot about supply chains these days, because if the past couple years have taught us anything, it's that an efficient, well-managed supply chain is absolutely critical to keeping businesses successful and consumers happy. I'm Will Haywood, and I host a podcast called All Business, No Boundaries, where we talk about supply chains, how they work, what happens when they don't, and the innovations that are redefining what's possible in the world of logistics. Join me for insightful interviews with thought leaders and industry experts. We discuss how optimizing supply chains can break down the barriers that are holding businesses back. That's All Business, No Boundaries by DHL Supply Chain. Listen and subscribe wherever you get your podcasts.
I don't think you'll need the racks anymore.
Interesting.
When we calculate the increased density that we can achieve and the increased throughput we can achieve at the loading docks because of the automated loading and unloading, we've been able to manage workflows for up to 6 levels of warehouses on a single floor.
Oh, wow.
The goal, the original goal here, and something that's still a big goal for me, is having real urban logistics, meaning warehouses really close to where dense population centers are, not 100 miles away, because that's where we found space for it. When's the last time you went to a warehouse and saw every part of that warehouse being used?
Yeah, that's true.
Never.
No.
Right? There's always empty loading docks. There's always empty space.
Yeah.
Why? Because everyone says, here's the worst case scenario designed to that. And because we're, somewhere in Pennsylvania or South Jersey where land is inexpensive, building a 350,000 square foot building or a 400,000 square foot building 400,000 square building doesn't move the needle for us. Okay. So just build a bigger one. Let's be safe. Maybe we'll grow into it, whatever. We're not thinking that way. We are saying, how can you get this done in the smallest space possible so that the activity is happening closer to where these things need to end up, so we can cut down on trucking, so we can solve the last mile, so we can take advantage of greener means of transportation that are available for short trips. You put a warehouse like what you see out in eastern Pennsylvania in the middle of Brooklyn, you're hitting 9 million people in a 15-mile radius.
Yeah.
Okay. There's not a warehouse out there operating at that scale that can claim that, because they can't fit in these spaces. And I'll tell you, when you get into a building that has more challenging conditions, meaning it's not a perfect rectangle, it doesn't have ideal column spacing, people tend to shy away from it, right? They're like, that's not going to work. It works. It works if you have a system like Logic that can map that space. Our AI figures out workflows that you wouldn't be able to see yourself by looking at it. It's funny because when you get into a non-standard warehouse, and we've been testing this in weird building conditions just to see what it does, the way the warehouse operates is not the way you would think. It's actually totally different, but it works, and it works better than trying to fit these old practices into what I think the future of logistics warehousing space is going to be.
Very interesting, and I think that makes a lot of sense, and certainly being able to adapt to existing facilities, especially ones that would be in like a Brooklyn or something that's been there for a long time and has a strange design. It's not a perfect rectangle as we often love to have in the warehousing world. I mean, I think it makes a lot of sense, especially for the future, and also from like a sustainability perspective too, just being able to reutilize old space and kind of bring that to almost a competitive advantage for a company to be able to get that close to the consumer and maximize that space and really see great throughput through there. So very interesting stuff, what you're doing here, Michael, with MetaLogic and the Logic Pallets. Very interested to see how this continues to evolve, and definitely interested to see it in operation as well. So why don't you tell us kind of what does the future look like for MetaLogic?
Well, the Logic Pallet and the Link Phase 1 system launched at the end of May of this year.
Mm-hmm.
So we're very happy about that. So the phase one system handles cross-docking and consolidation and deconsolidation operations, meaning you load items on the pallet, on the Logic Pallet once. It may go through multiple facilities and multiple trucks, and then it's unloaded at the end. So those workflows are available now, and we're taking pre-orders today to bring robots into people's spaces in the summer of next year. Phase two for us on the Logic Pallet side is going to be picking. So we have our own picking arm that is still in development that will come out to complement this. So making mixed pallets is phase two for us. And then as supplemental add-ons to the Logic Pallet for either phase one or phase two systems, later this year, we will be releasing our fabric and container top. So we have a refrigerated or frozen container top, depending on what temperature you need, that keeps goods cool passively.
Yeah.
We call it Logic Ice for integrated cold container. But it's a cooler that is part of our pallet, so that if you have refrigerated or frozen items that need to ship on non-refrigerated vehicles between refrigerated facilities, you can pack them in this instead of putting them on a reefer truck. We also have a fabric enclosure that is an alternative for all of the single-use plastic that we use to wrap the pallets. So instead of wrapping this, because if we go on a truck, you still have to wrap it. If the truck is bumpy, the goods will fall off just like they would a regular pallet. So instead of wrapping it in plastic, we have our own integrated reusable fabric top that secures the goods to the pallet as when it's on the road or when it's moving throughout the warehouse.
Oh, wow. I love that. I mean, that makes a lot of sense. I was just talking to somebody the other day about the vast amount of plastic wrap waste that is generated by the warehousing industry. So I definitely love to hear that you guys have come up with kind of a alternative solution there.
I heard a staggering statistic on the plastic that in the U.S. alone, each of us use almost 40 pounds of plastic wrap a year in shipping, meaning my burden on the supply chain, if you divide that out by our population, we generate about 40 pounds of plastic wrap a year. Now, if I took a ball of plastic wrap the size of me, what is that going to weigh, like 2 pounds?
Yeah.
It's so light. So when you think about 40 pounds and then translate that to a volume of something so light, that is a lot of single-use plastic.
That's crazy. Yeah.
And we'd love to get rid of that, all of that.
Absolutely. That would be a great thing. And the Logic Ice, I mean, you said it can replace the reefer truck need potentially, but I mean, could you also utilize that? Say you had an ambient storage space and you needed to keep some cold stuff in there. I mean, could you use that as almost like a freezer or refrigerated space within an ambient space?
You could. It uses a refreezable panel solution that we created. So it's a passively cooled box. So there's no compressor, there's no power to it. So it is limited for how long you can last. So it's ideal for like a 24-hour or less journey where you've got a regular truck going with some extra room on it, and it can stop at a cold storage facility and pick up a couple of pallets of ice cream in one of our boxes and drop it off at the same supermarket, for instance. So the way a lot of our beta customers do it today is they will take a reefer truck, put the frozen items closest to the front of the truck where it's coldest, and then put up a piece of insulation on plywood, let's say, to create a divider, then put refrigerated items, then put another divider and fill up the rest of the truck with non-refrigerated items or whatever else is going on this journey. And those reefer trucks require a lot of maintenance. When you obstruct the airflow in there, it further degrades the life of the compressors and things like that. So we're just doing the inverse. We're saying put it on a regular truck and whatever's refrigerated or frozen will go in this box, and whatever's not is not. And they can all go together as long as the journey is within that time frame, which we really haven't found a use case that exceeds how long we can last just, once we're in there. But it's really like a cooler attached to this mobile robot.
Very interesting stuff. Yeah. Very interesting. Very, very smart.
And that enclosure also doesn't have to be refrigerated. So it's a rigid enclosure that's lockable. So if we're talking about non-refrigerated valuable items that you want additionally locked, you're on a 3PL and you're sending valuables and you're LTL. So there's other people on there and it's going to stop at other people's facilities before you, and you have concerns. Now they can't get into it. And because our pallets are connected, if someone tampers with it or tries to open it before it's allowed to be open, you get an alert on it. You know exactly when and where that occurred. So the enclosure is multi-function, but the biggest demand we see for it right now are the refrigerated and frozen functions for grocery and pharmaceuticals.
Yeah, I can imagine big demand there. So really interesting stuff. Very, very smart. Very logical, I would say, as well. There. So
that was the name. That was the name. The logical solution to logistics.
Yeah, absolutely. So really interested to see how this continues to evolve over time. And I think it's really smart the way you guys have thought about it, and very interested to see how it continues to grow. So if people are interested in learning more about MetaLogic and the Logic Pallets, how can they do that?
Well, you can go to our website, which is www.logic-os.com. There's a contact page right now. We are launching our product pages on there in the coming weeks, so you'll actually be able to see these things. Right now, our pre-orders are limited to the beta partners that we've had prior to launch. Once we get to that maximum, we're going to open it up to the general public. You'll be able to request a price assessment online for your facility. So what we do is we come in and map your facility, we digital twin it, and we figure out a workflow that optimizes for your needs. And then from that, we're able to determine how many Logic pallets you need, how many charging stations you need, all that other stuff. But you'll be able to see the products on the page and understand what you have and see. There is a live demonstration of the software, a brief one, on the website right now. And if you contact us, one of our sales team would love to give anybody a full demonstration of how all the software works. It's really like a first-person view of what a warehouse manager would see operating a warehouse running under the Logic system.
Awesome. And definitely interested to see that and what all that stuff kind of looks like as it's operating together. And we'll definitely put all that information at thenewwarehouse.com as well. So, Michael, thank you so much for coming on the show today and telling us all about MetaLogic.
You've been listening to the New Warehouse Podcast with Kevin Lawton. Subscribe and check us out online at thenewwarehouse.com.
Thank you for listening to this episode. If you want more content from the New Warehouse, check out our new video series called All Hands on LinkedIn. Just search for the New Warehouse on LinkedIn and follow along.